Let's have a look at an IRR example. And we know it's an IRR not only because that's what the question mark at the top of the page is, but also because this is a standard cash flow. It only has a single change in sign, and so that makes it a standard cash flow. A non-standard cash flow would have more than a single change in sign, and then we would have to use the external rate of return method to first convert the cash flow into a standard form, such as this, and then solve for the unknown rate of return, the unknown interest rate. This is a typical investment. We've put in a little over $75,000 into the investment up front, and then we're going to receive some kind of net revenue over the remaining 10 years. And at the end of 10 years, this investment is over. So whether that's a piece of equipment and there's no salvage value or whatever, it doesn't matter. This is a fairly straightforward cash flow. We can look at this. There are two approaches, two methods that we can use. The approximate IRR method as well as the precise. If we're looking for a specific rate of return, then we need to use the precise method. We can use the approximate method when all we're looking for is a decision. So in other words, if all we wanted to know was if this project would be a good one to invest in. We know the MAR, so we can move all of the receipts forward at the MAR, and we can then compare that to the disbursements all moved forward at the unknown interest rate. So in this case, certainly we know what the MAR is. It's 8%. We can look up that information in the table. So the 12,000, the 350 gradient, both of those can be calculated easily enough, and we would have this equation, and we would be able to solve for this particular interest factor. And we would get out of remanipulating this equation, we would end up with a fraction, a number that we could then compare on varieties of tables. And this was very useful in the days when sets of tables were printed in whole number interest factors. So we would have a table for 1% interest, we'd have a table for 2% interest, we'd have a table for 3%, 4%, 5%, etc., etc., etc. And certainly in the days before spreadsheets and calculators, that was very convenient. We would have typically a book that had a set of tables in it. Sometimes those tables were very detailed and would have fractional interest rates, typically in quarters. So you might have 8 1/4, 8 1/2, 8 3/4, 9, 9 1/4, etc. Typically because mortgage rates were often quoted in quarters. And so those kinds of interest tables were published, and you looked them up, the numbers manually, and using the approximate method was fairly quick, and the computation that was left over was fairly simplistic. So it was a good method if all you wanted to know was if this investment was worthy of pursuit, because as long as the unknown interest rate that we calculate is above or equal to the MAR, then this would be a good investment. There is a proof out there that shows that the unknown interest rate using the approximate method will always fall between the MAR and the precise IRR. And so we could use that as a decision-making tool. So if we needed to compare two different projects and decide which one to invest in, we could apply the approximate method and find an answer to that decisional question. If, however, we need to know the precise IRR, which is what we need most of the time, the easiest way today is using a spreadsheet. We can easily put in the cash flow itself. There are functions within Excel, or we can use the interest factor table and create fairly quickly a little model that represents the cash flow, and we just simply go in and through trial and error try a variety of interest factors until we narrow down to the one that we're interested in, to the number of decimal places that we require. So for this one, that's what we're going to do. We're going to use the present worth, setting it to 0. The 12,000, we're going to bring that back to a present worth. The gradient, it is, and the reason it is over 6, it isn't 6 because if you count the number of arrows, there's 1, 2, 3, 4, 5, plus 1 for the 0. Remember, gradients always have a 0 starting point. And so this gradient is over 6 years. And with the same thing as with the annuities, there's always a 1 time period lag between, so the P over G interest factor, when we apply that, it converts all of that cash flow into a single lump sum amount at the end of year 4. There's a 2 time period lag to the first non-zero, the first arrow in the gradient, or if you remember the 0, there is a 1 time period lag from the starting point of the gradient. And so in that case, we need to bring this again from the end of year 4, that lump sum, to time 0. And that's what the P over F at the end of the equation is. Notice in the approximate method, because the P over G will in fact drop the money again at the end of year 4, we need to bring it forward 6 time periods, 1, 2, 3, 4, 5, 6, to get it to year 10. Because in the approximate method, we're moving everything to the future worth, whereas in the precise method, we're moving everything as a present worth. Yes, you can also use an annual worth and future worth calculation, setting to 0 with the precise method, and it will work if you make the correct adjustments. However, the definition for the internal rate of return is the present worth of the cash flows are set equal to 0, and we solve for the unknown interest rate. And as I said, the easiest way to do that is to use a spreadsheet. So I'm going to quickly flip over to my spreadsheet here. And the interest rate to start with, usually the MAR is a good guess to begin with. See if that works. So we can just type in our numbers. It's 75,220 as an initial upfront cost. We have an annuity of 12,000, and we have a gradient of 350. And so we're interested in the present worth. So the 75,220 is already at time 0. It's already as a present worth. So we don't need to make any adjustments to it. The annuity, on the other hand, we need to multiply that. We need to multiply that times a P over A for 10 years to get us what its present worth is. And then for the gradient, it's a little bit more complicated. One more step. It's the 350,000. It's times the P over G 6. And then it's times the P over F 4. And that gets us the present worth of that gradient. So we then add the 3 numbers together, do an auto sum, and it's 8,000. So it's a positive number. It's obviously not 0, so our interest rate is not correct. So we just trial and error. So let's start and let's say 9. Oh, it's moved it closer to 0 by going to 9. Okay, so let's try 10. Yep, it's getting closer to 0, so we're moving in the right direction. Let's try 11. Oh, it's gone negative. So that tells me right away that the interest rate we're looking for is somewhere between 11% and 10%. So let's try 10.5. It's still negative, so that tells me that the number is between 10 and 10.5. So let's try 10.25, 10 and a quarter. That's getting closer. Now it's on the high side, so I need a number between 10.25 and 10.5. And so let's try 10.3. Oh, it's gone negative. So 10.26. Oh, it's still negative. Okay, so it's between 10.26 and 10.25. Right? 10.25 is a little bit closer. So we could continue using more decimal places. We could try 10.51, 10.52, and continue in that fashion until we, depending on how many digits we actually required. For this example, I think that's close enough. 10.25%, it's pretty close to 0, and I'm going to call that a day. And that's really all there is to it. It's a trial and error method. It uses the interest factor table. It's pretty quick. Certainly that's a lot faster than trying to solve the formulas to come up with a more accurate internal rate of return percentage. And really, in today's world with spreadsheets, not necessary. There are built-in functions within Excel that would allow you to calculate the IRR if you spelled out the entire cash flow. So you could go and spell out the 12,000 all the way along, add in the 350 at year 6, and add in 700 at year 7, etc., etc., and solve for it using the built-in function as well. I'm not going to get into that. Particularly in this case, it's only 10 years. It's not that challenging. But if you have longer years, then it becomes more challenging to type out all the numbers. And sometimes using the interest factors themselves is still much faster, much quicker. Just simply build a little model, check the numbers, play with the interest rate, and you'll be able to solve IRR questions in just a few minutes.